Everyone, today we'll be discussing about the topic network layer, the concept related to the network layer we will be discussing in this session. Okay, so let's check how the network layer works and where the network layer belongs in the OSI model. Okay, so OSI model already has 7 layers in the network architecture. The 7 layers are, you all know, physical, data link, then you have network, transport, session, presentation and application layers, and the network layer is said to be present in the third position. Okay, so mainly what is the work of the network layer is to deliver the packets to the destination in a proper way. That is the main aspect of the network layer. Okay, before anything happens in the network layer, the topology which is being used for communication, it has to be known. Okay, the appropriate path to route the information from one end to another end, that important thing, it should be known. And when the route is being selected, it should be checked whether the path is said to be free or whether it is said to be occupied by any of the other aspects. That is being checked in the network layer. Okay, this part is being there. And even in the network layer, you will be discussing the various paths. One of this thing is the issues related to the network layer is being discussed. Then the routing of the things is being considered, and then you have the network layer in the internet. Okay, so the network layer design issues, there are 5 design issues when they are said to be considered. One is the store and forward packet switching. Then you have the service provided to the transport layer, that is being considered. Then the connection less service and connection oriented service is being considered, and the comparison between the virtual circuit and the datagram subnet is being considered. Okay, so what is store and forward packet switching? You all know what is the meaning of the storing and forwarding. So before the layer router becomes free, the other things which are being occupied over the line, it has to be like checked whether all the things are being flown to the other end, whether any of the busy lines are being there. If busy lines are there, it has to be stored on the nearby router, your data. Then it has to be forwarded to the other. So here the information passes here from A to B, B to D, then D to E. So when it is being passing the information, it has to check whether router is free or not. If it is free, then only it will be passed the information. Otherwise, if it is not free, the router stores the information there only, and later when the line becomes free, then it will be passed. That is called as the store and forward packet switching. Okay, so this is the aspect, as I said, what happens in the store and forward. Store and forward aspect is nothing but the nearest router, it passes the information through whichever LAN it is there, or it carries the information from one carrier to another carrier, from one point to another point. It verifies whether the router's path is said to be free or not. If it is free, it passes and it reaches to the nearest host which is being present. That is said to be happening in the packet switching aspect, that is the store and forward aspect. The second design issue which is being considered in the network layer is the services which are being provided to the transport layer. What service is being provided by the network layer to the transport layer? So more important aspect is that whenever the information which is being passed, it should be free of the router when it is passing the information. It is not dependent on the router technology that is being provided. Then whenever the information is being passed, the information which is being passed or the data being passed, it has to have the sequence number. It should be mentioned with which kind of data it is said to be present and what topology it is being used in the network layer when it is being passed to the transport layer. That information it should be knowing, and even it should be having the network addresses. It will be following the different kinds of addressing techniques, class A, B, C, D, E, that techniques, and the uniform addressing of the various things is being provided. Uniform addressing is nothing but it has to be of 32-bit address which is being divided into 444 like that, or 888 division aspect is being considered when it is said to be addressing part. It is either LAN or WAN. The addressing, it should be divided into 888 bits like that. Okay, which covers the 32 bits. So 8 split your whole address, it will be divided into 4 parts. In each part it will be having 88 bits. That is said to be the networking address part. So one of the scenarios which is being considered is when the information is being passed, it will be passed over the subnet. That subnet, it passes the information from one end to another end. When it is being passed, it is said to be unreliable on the whichever network is being used, but it should manage the error control. The unreliable network, whichever network, it is said to be unreliable. When it is unreliable, it should be checked whether it is error free or what. The whatever information is being passed, it should be error free, and the flow control mechanism is being used when it is said to be a connectionless aspect. Okay. One is this connection oriented. Main thing is that it gives a good quality service when it is said to be connection oriented. Without any problem, it should be like considering the information to be delivered to the other end. It is said to be a real time traffic which is being managed. Even it manages the voice and the video over the network. So these things are being considered in today's session. You have learned about the first aspect, that is what store and forward technique in the network, and even it will, you have learned about the services which are being provided to the transport layer, which are the issues of the network layer. Other three issues we will be discussing, that is these three issues I will be discussing in the next session. Okay, thank you.